So here's the current state of our inventory window. Over the last several videos, we've created the infrastructure for creating items and for modifying the inventory state of the player. But right now, we have a bunch of empty item slots and no way to move items between the slots. So let's change that. The focus of today is going to be to add the interactivity to the item slots and actually get some items in the inventory window for us to play around with. So let's draw our inventory grid slot here and define the behaviors we want. We want to add or remove items, hover state and item tooltip, and drag and drop, just to name a few. And then we're going to take these and define interfaces that we're going to use to extend the behavior of our inventory grid slot and allow us to use this inventory grid slot in more than just the inventory window. Back in our project here, let's create some of these interfaces. So we'll define item manager, drag manager, and the pointer event manager to start us off. And then we're going to go ahead and define what the pointer event manager is. So there's three different methods we want to capture here. There's pointer over, pointer out, and pointer up. And all three of these are going to take in the phaser pointer object, which has information about the state of the pointer. Now let's go ahead and implement the pointer event manager interface. So we'll create a new class, the inventory pointer event manager. And its responsibility is to handle all of the pointer events within our inventory window. And it's going to take in a couple of parameters here, the scene and the item slot. And the first thing we need to do is hook into phaser's interactivity on the game object for the slot sprite and define three properties, the drop zone, the hit area, and the hit area callback. The reason we do this is so in the future when we build drag and drop, the item slot can act as a drop zone and allow us to build out that drag and drop functionality. But in addition to that, we need to also wire in the individual pointer events that occur, and Phaser exposes an event emitter in all of the game object in the game, so we can do that now. I don't want you to watch me fumble through all of this, so we can just fast forward to the end state and then talk about where we landed. So here's what we have right now. We've implemented the handle pointer over, and all it's doing is setting a border around each of the inventory grid slots whenever you move your mouse over. But we got a couple of squigglies here, so let's fix those. So let's hop back over to our inventory grid slot and stub out some of these functions that it was complaining about. We need has item, and we need show item info. And for now, we don't really care too much about what they do. We'll add the logic for these later. So the next thing we need to do is create a property that'll hold the reference to our event manager. And so we'll go ahead and do that now. Since we want this class to be flexible, we're going to have it take in the pointer event manager as a parameter into this register managers function. And then we'll call that from within the inventory grid slot factory. So slot.register managers, and we'll create a new instance of this class, get it all set up, and we should be good to go. Let's check our progress here. And we've got item hover, but they don't deselect themselves when you move the mouse out. So that's a problem. And we need to fix that next. So let's hop back over here. We're going to paste this code in. It does almost the exact same thing as the pointer over event, but sets the frame back to the original version. So this should fix our problem. Let's give it a run and see. And there we go. Awesome. We fixed it. We now have the hover events working correctly. But now let's move on to the item manager. In this class, we'll be responsible for adding or removing items, and we're not really going in any particular order here. So we'll define that interface. We're going to add several methods here to allow us to interact with the item slot and provide a way to sort of abstract the things that the item slot can do into this interface. But let's go ahead here now and jump ahead to the finished definition, and we've got to now define an item class that'll expose some functionality for the item itself as it sits inside of the inventory slot. So we'll create a new item class here. And then we'll define the parameters that we need. So item sprite and a config object that'll just have some information about the item that's being added. We need to actually go now and add the add item config definition. So let's hop over here to our inventory grid slot. And let's crank that out really quickly. So just an interface with a handful of properties to help us define what this item is. So here's the finished product of that config object, and then we'll jump back over to the item, and let's wrap this guy up. So a couple properties we need to set here. Now, I don't want to spend too much time on the item right now, but it will come into play once we get into the drag and drop functionality. So we're just going to grab a reference to the game entity, and then we'll grab a reference to the initial position of the item sprite, which will come in handy again once we get more into the drag and drop stuff later on in this video. But But really the next goal is going to be to define our inventory item manager. And that's going to let us actually add items, update quantity, and do all the fun stuff that we want to do. So I know it's taking a long time to get there, but let's go ahead and now and define that class, and then we'll implement the interface. And now we've got to define all of these methods. So let's get rolling on that. Let's define our add item method that takes in a configuration object. And the first thing we'll do is we'll create a new sprite based off this item's configuration. So we'll call this function in our item sprite factory that takes in the scene, the X and Y position, and the frame of the image, and it spits back out a phaser sprite. Then we've got to create a new item class, which is what we just created a few minutes ago. And we'll give it the item sprite and the configuration, and then we'll set a private reference to it so we can use it later on in our other methods. Now, the next thing we need to do is check if the item has a quantity, because if it has a quantity, we want to display the quantity amount in the item slot window. And then we'll obviously just grab a quick reference to the quantity so we can update it later and update our typings here. And of course, make sure that we actually add the quantity game object to the item slot container. Otherwise, we won't see the number that represents the quantity. Now, the next thing we need to do is make sure that the item sprite is visible within the item slot. So we've got to set the depth. And I chose an arbitrary number, 201. You guys can pick what you want. It might depend on your use case, what number that ends up being for you. Then we'll make sure we return the item back to the caller. Now, I did realize that we forgot to add the parameter to the interface definition. So we need to go back to the item manager and do that really quickly before we move on. Here's our finished inventory grid slot item manager. We talked through the add item method. The other methods here don't really have too much going on. Update quantity, hide item, show item are all very simple and straightforward. Has item as well and get item as well are also pretty straightforward in my opinion. Remove item has a little bit of extra complexity to it. The way it works today is we actually, not only do we remove the item sprite from the slot, we also destroy the item sprite. We destroy the quantity game object if there is a quantity game object. We set the item to null, and then we return the item ID because in some cases we want to know what the item ID of the removed item was. Now, you could also preserve the item sprite and reuse the same item sprite, but I found it easier to just delete it and then re-add it in whatever the new slot is that you're adding an item to. So it's up to you if you want to follow this pattern or develop your own, but that's the way that I chose to do it. And now the time has come to actually get the items into the item slots. So bear with me, over the next few minutes, I'm going to create a number of new files here. And then at the very end, we'll do a recap on how everything's connected, and I'll explain why we chose the pattern that we did. First up here is our inventory grid manager, and its responsibility is for handling all of the item interactions with the inventory grid slot directly. And in that case, it receives a reference to all of the inventory grid slots that we created. We're going to expose a couple methods here: add item, get slotted index, and eventually we'll add a remove item as well. So let's go ahead now, just crank this code out. And we'll have to do some plumbing here to get everything wired in correctly. So we've got to add this new method in our inventory grid slot called add item. And you've probably seen us add this method in a number of places. The add item method inside of the inventory grid slot is going to defer its functionality to the item manager class that we already created. So we just need to set up a reference to the item manager class. And then we'll pass it in via the register managers function like we did with the pointer event manager. So then we'll have to go back to our inventory grid slot factory and pass a new instance of our item manager class into the register managers function so that we have a reference to it. Again, bear with me as we work through a number of dependencies to get this thing wired in. Next thing we'll need to do is go back into our inventory window manager, which we have not yet created. So let's head back over there and let's define this new class, the inventory window manager. So it takes in two properties in its constructor, the scene and a reference to the inventory grid manager that we just created a few minutes ago. Now, inside of this constructor, we need to listen for a couple of events. So to do that, we'll use the inventory event emitter that we already created earlier on in a different video. And if you missed that video, I believe it was the third part of the series. And this is where we actually raise the item added event. So it's whenever an item is actually added to our player's inventory, not the UI, but the actual inventory state that we track behind the scenes. Now, I can see here that we've got to define another function called decompose item. And all that function is going to do, it's going to take the game entity that has all of the components on that item and create a nice little object that we can pass in as a parameter to the add item function. And we're going to do that here. So we'll define a function called decompose item, take in the item entity, and then we'll return the add item config, which is just an object again with the components that the item manager needs to know about. We don't need all of the components of the game entity, so we'll break it down. Grab the renderable, the quantity, do a little save, and then we'll go back into our add item config just to fix the typings, and then import the decompose item. And make sure that we check for undefined for both of these components. And after sorting through the remaining errors, we landed on this. So you saw add item. We added remove item as well, which utilizes the same get slot at index method. All it does is checks to see if there's a slot. If there is, we remove the item, and then we call the layout function on the grid to make sure everything realigns itself. And that's really all this is doing. All right, so let's recap here. We can break our system into 3 parts: gameplay rules and state management, the mediator, and the presentation layer. In the last 2 videos, we spent most of our time defining the entities that represent all of the things that live in our game world. And so that included defining the player entity and all of the items that live in our game. And the way we did that was we broke the things down into components, which really are just attributes that define what those entities actually are. And then we took all of those entities and built a way to actually modify the state. We're actually modifying the state of the components. Now, the piece that we're missing and what we've actually worked on today is the whole right-hand side of this diagram. So let's talk about it. Our mediator is the thing that listens to events from both the ECS, which is our state management piece, and the UI. And it's responsible for routing all of the requests from the UI to the appropriate action to modify the state of our inventory window. It then receives an update that state has been changed, and then goes and re-renders the UI. Let's draw out our presentation layer, and then chat a little bit about how it relates to what we've already created. So if you remember, we created the inventory grid manager. And the inventory grid manager is responsible for managing all of the inventory grid slots in the window. And currently, that's just the ability to add and remove items. Now, if we drill down into the inventory grid slot, we've created 2 of the managers responsible for behaviors related to adding and removing items and handling all of the pointer events. What we haven't done yet is added any drag functionality. We also don't have item tooltip information yet. So those are things we still need to get done in this video. I don't know about you guys, but I'd like to see some progress. So let's create a new instance of those 2 managers that we just worked on. So the inventory grid manager, we'll return a new version of that inside of our inventory grid factory. And then we'll update our inventory window to take in the grid itself. And first, we've got to quickly change this to public read-only instead of private. So we can grab the grid and add it to the inventory window. Now we need to add an instance of our inventory window manager. So let's do that, and we'll pass in the scene, and we'll pass in the inventory grid manager. Now let's open up our inventory window and check progress. And there we go. We've got all of the different items added to our inventory slots. Now, obviously they're missing the item sprites. So we've got to go back to our main scene, and in the preload function, we'll add the logic for pulling in the actual item atlases, allowing us to render the items. All we've got to do is uncomment this code and we should be good. So let's give that a save and refresh our inventory window. And awesome, for the first time, we've got real items in our item slots. If you're still listening, pat yourself on the back. This is a nice little milestone, but we're still missing all of the normal inventory window functionality. So this is cool and all, but we want to add drag and drop still, and we want to see the information about the item whenever we hover over. So let's do that, and we'll round off this video. Now for our drag manager, we're going to do a shameless copy and paste. I don't think there's a whole lot that needs to be explained here. Essentially, this is going to allow us to handle different drag events that occur within the inventory window. Now we need to create a class that implements this interface, inventory drag manager.ts. And we'll do another copy and paste here. There's quite a bit of code, so let's talk about it. So if we scroll up to the top here, we can take a look at the constructor. Most of our managers take in the scene and the item slot. The drag manager also takes in a third parameter called getValidDropTarget. And this allows us to specify some logic that will validate that wherever the item is getting dropped, we can check that it's a valid target. In some cases, there might be inventory slots that you don't allow items to be dropped in. So by passing it in via the constructor, you can pull that logic outside of the drag manager class and let something else define it. Whenever this class is created, we subscribe to the item added event. And the item that gets passed in here is the item that we created earlier in this video. We then subscribe to the item sprite. There's three different things that we care about: the drop, the drag enter, and the drag leave. All three of those we have handlers for as defined by our drag manager. So all we do simply is invoke those methods whenever the event occurs. So what do these handlers do? Well, in each case, it takes the item slot sprite that the mouse is currently over, so you can picture dragging an item over an item slot, checks to see that that's a valid drop target. If it's a valid drop target, then we'll publish an event. And for each of these, we have an associated event that we want to call, and we've typed those event payloads to allow us to easily know what parameters we need to pass back up to the listener. So drag enter and drag leave both occur before the item is actually dropped. So before you release the mouse. Once you release the mouse over an item slot, not only do we validate the drop target, but we call a couple of helper methods on the item class. So we need to go add those. Now I've already added them, but we need to define the logic for what these methods actually do. Now first, let's move these two methods down below the constructor because I don't like having them at the top. Now, resetting the item position is easy, and this happens whenever the item is dropped. If it's not dropped in an item slot, we want to reset the position of the item sprite back in the original position it was at. So that gives it that nice snapping effect. So we'll just paste this code in here. Should make sense, not going to explain it too much. We do want to define handle drop, but there's still some more logic we need to add in the item class to allow it to be dragged appropriately. So let's make our item sprite interactive. Whenever the player clicks on an item, we want to be able to handle the drag and drop functionality. So we're going to hook in the pointer down, and inside of this pointer down handler, we're going to call a method that we'll create called handle drag. There's a decent amount of code we need to write for handle drag. I'll go ahead and do that, and then we'll come back and explain where we landed. All right, so let's recap here. The first thing we want to do is grab the starting position of the pointer. Then we define an isDragging and a drag threshold variable. The drag threshold allows us to define the number of pixels the pointer needs to move before we actually start the drag. We'll then add an event handler for pointer move. And inside of pointer move, we do a quick check to see if the pointer has been released. If the pointer has been released, we just call handle drop. If the pointer hasn't been released, if the player is actively dragging the item, we want to check the distance that the mouse has traveled from the starting position. If the pointer's gone further than 10 pixels, then we know that the player is actually trying to drag, and we want to initiate the drag. So inside of our initiate drag method, we get a reference to the drag plugin. We then tell the drag plugin that the item sprite is the thing that we're actually dragging. Then we set the depth of the item sprite to 999 so that it goes to the top of the stack, and we can easily see it on top of all the other items. And that's really pretty much it for the item class. The only other thing that we need to do is make sure you turn off the pointer move event handler whenever a drop occurs. Otherwise, you're going to have instances of this pointer move event handler firing consistently, and that could eat up your memory and end up causing some sort of memory leak. So make sure you turn that off. But let's keep it moving. So we're pulling in an instance of the drag plugin, but we haven't yet registered the drag plugin with Phaser. So let's go ahead and do that. We'll hop over to our Phaser config, and I have pulled it in. So take a look at the plugins object here. We want to pull in the drag plugin from the same bundle as we pull in the UI plugin, and then make sure you register it as a global. All right, it's time to check progress. As you can see, we can drag items around, but they're not snapping into the item slots. In fact, they're not really calling any of the game logic itself yet. This is because we're not listening to any of the drag events. So the logic for updating the state of the inventory is not actually happening yet. So let's hop back over into our inventory window manager and add the drag events here. And we'll just paste this in there and boom, now we're listening to the drag ended event. And whenever that event occurs, we know we want to get the item from the current slot and tell our game logic that it needs to update the slot of the item and move it into the landing slot index. After a bit of tinkering, we finally got drag and drop working. So I can move items around in the different item slots. We snap the item back to its original spot if you drop it outside of the window somewhere.
And under the hood, we're tracking all of the inventory state. So we've got a reference to the slot index that each item is in, which would allow us to do item filtering, which we'll handle in the next video. I think we've reached a pretty good stopping point here. We've covered a ton of stuff in this video. As a reminder, if you'd like to follow along with the code is actually on my GitHub. And so I'll put a link to that in the description. Each commit in that commit history will correspond to a particular video. So you can literally go down one by one and see the progress that we've made across the different videos. In the next video, we're going to take on the item tooltip and then also work on the item filtering. And that should be the last video in the series. So look forward to seeing you guys there.